All right, good evening again, guys. So from the previous class, we were on the topic of Pythagoras' theorem. We saw that Pythagoras' theorem is applicable to only right angle triangle. And based on the right angle triangle, we see that the theorem also exists in terms of a formula. And that formula, we start the formula based on the longest side of the right angle triangle, which is the hypotenuse. So whatever that side is, we would start the formula with that. Anybody can just give me a little, what must I say? Just give me a review of what the formula really is. Somebody just state what the formula of Pythagoras' theorem is for me, please. Anybody? Miss Brown, can you state the formula for Pythagoras' theorem for me? Just for review.
I don't remember.
B square equal.
All right.
A square plus C square.
Is that Miss Waysome or Miss Green?
Sir, are you hearing me?
I'm hearing you, but you're a little your reception is a little.
Sir, are you hearing me?
I'm hearing you, but your reception is a little off.
Are you hearing much better now?
Much better now. All right, go ahead.
Right, so I was saying square plus.
All right, so just take the formula for us now. Miss Wade,
Yes, sir. Are you hearing me? I was saying B square equal to A square plus C square.
okay, I would like you to qualify that definition a little more, or specify it a little bit more, because remember,
With B the hypotenuse, sir, which is the longest side, and then A the smaller sides are the adjacent. So, all right, the hypotenuse equal to the adjacent plus the opposite side, sir. Does that work better?
well, it is not exactly what the theorem states, but I kind of see what you're trying to say, but can anybody give me the exact statement for the theorem? You want to think about what you just said a while ago, Ms. Waysome, and probably say it again?
Or was it not the formula you asked for?
Yes, and restate what you said just now. Hello, Ms. Waysome, are you there? Mr. Lamar, are you there, sir?
Yes, sir.
You want to just state the formula for us, please?
The formula for
Pythagoras theorem.
sir, A squared equals B squared. Or hypotenuse squared equal adjacent squared plus opposite squared.
All right, so that would be a more specific way to give the formula. The hypotenuse square is equal to adjacent square plus the opposite square, or you can say opposite square plus the adjacent square. Now, in general though, most most of their texts would have it in general starting with A. So it would be A squared equal to B squared plus C squared. All right, and that is a theorem, and it only applies to right angle triangles. So can you give me an idea, when do we use this theorem in terms of a right angle triangle? What can we use this theorem to do when for a right angle triangle?
Find the length of the hypotenuse.
Only the hypotenuse?
So you can find the length of each side of with any side of the triangle knowing two sides.
Okay, so if you want to find a length of one side of a right angle triangle and you know the other two sides, then you can apply the theorem. And that's usually how the theorem is applied. So generally I ask to find the length of one side given the other two sides. So you can only apply Pythagoras theorem when you're given two sides of a right angle triangle and you're asked to find the other side. Now, sometimes it may require that you do some manipulation to the formula in order to find either the opposite or the adjacent. But if you're finding the hypotenuse, you keep the formula as is and just substitute the values for the opposite and adjacent, and then you do the calculation for the hypotenuse. All right, guys, so with that said, from the previous class when we were looking at Pythagoras theorem, we had looked at some questions and we were now introducing isosceles triangle. And today I'm just going through the properties of isosceles triangle once again, and then we'll see how we can apply Pythagoras theorem to an isosceles triangle. So just to check your knowledge of isosceles triangle, can somebody describe, or should I say define an isosceles triangle? Can anybody define an isosceles triangle for me? What is an isosceles triangle?
Sir?
Yeah, go ahead, Lamar.
Sir, an isosceles triangle
Yes.
is a triangle with two equal sides and an unequal side.
Okay.
There's two sides would have the same length and one would have a different length.
Okay. All right. Anything else you can say about the isosceles triangle in terms of properties?
So what properties do you mean?
What are some of the features relating to an isosceles triangle?
Sir, two equal sides, one unequal side. If you split it, you can split it in half and get two right angle triangles.
Okay. Anybody else want to add to what Mr. Lamar is saying? All right, so just to add to what Mr. Lamar is saying, so we say an isosceles triangle has two equal sides and one unequal side. So that side is not equal to the other two sides. Now that the unequal side is usually the side that we put the triangle to sit on. And that side, the unequal side, is generally forming the base of that triangle. All right, so the base is the side that it is sitting on. All right, so we would have the two unequal sides meeting at the top of the triangle. Sorry, the two equal sides will be meeting at the top of the triangle. And the angle that they form at the top is referred to as the apex angle. And the angles that are at the base on either side of a triangle, we call those the base angles. All right, as Mr. Lamar said, if we draw a vertical line from the apex to the base, which is the side sitting on the floor, we cut that vertical line will cut that isosceles triangle into two right angle triangles. And so in that case, we can apply Pythagoras theorem to an isosceles triangle because we can form right angle triangle from it. And anywhere we have right angle triangle, once you have two sides, two known sides, and we want to find the third side, we can always apply Pythagoras theorem. All right, guys, so is that clear to everyone? All right, so some important properties to look at. Now we say the apex angle is the angle at the top of the triangle. So at this, the apex angle would occur at A. All right. Now, just to give you an idea of what the apex angle really is, ignoring the line, ignoring the vertical line, the apex angle is the angle going all the way across. So this would be your apex angle. All right, so let's say we didn't have this vertical line here, then the angle between the two equal sides forming at A would be your apex angle. All right, now if we have that vertical line drawn from the apex to the base so that it meets the base at right angle, we know that the base, which is the unequal side, will be cut into two equal parts. All right, and the apex angle will also cut into two equal angles. All right, so up at the top here where we have the apex angle split into two. So this side of the apex angle, so the left side of the apex angle and the right side of the apex angle would be actually the same size angle. All right, so if you call that side theta, then the other side is also theta. So that would be the apex angle. Now the base, which is the unequal side, this line is perpendicular, and just to clarify what a perpendicular line is, before I actually do so, can anybody tell me what they know about perpendicular lines?
So perpendicular lines form a right angle.
All right, so when we say two lines are perpendicular, what we are really saying is that when the two lines cross each other, they cross at right angle. Now, so you may have a horizontal line crossing with a vertical line, and they will form right angle. So horizontal and vertical line will form perpendicular lines when they meet. All right. Now the base, which is the unequal side, is perpendicular to the vertical line from the apex angle. So it's perpendicular, and hence we have right angle. Now, the side is cut into two equal parts. That is the unequal side. It is cut into two equal parts. So from B to D, if the length of that is X, if B to D is X, then it also means that on the other side, from D to C, can anybody guess what the length of that would be?
Sir, can you repeat?
Can anybody guess what the length of D to C would be?
So, but
X
there are no
squared, sir.
measurements.
So it will also be equal to x. And why it is equal to x? Because this vertical line cuts the base in two equal parts. So from B to C is the same length as from D to C. From B to D is the same length as from D to C. Is that clear, guys? All right, so the base angles, so we have two base angles, one forms at B and the other forms at C. These are the base angles. Now, the base angles are also equal angles. Can anybody tell me why the base angles would be equal? So let us call this one alpha. And this one would also be alpha. Can anybody tell me, give me a reason why the base angle would be equal? All right, so the two right angle triangles that are formed by the line cutting it from the apex, the vertical line from the apex to the base. The left right angle triangle, which is the triangle ABD, and the right angle triangle, which is ACD, they're actually mirror image of each other. Meaning that you can fold them along the vertical line and they match perfectly when they fold on each other, right? If you ever fold what we call a heart over onto itself, a perfectly drawn heart, the left side will match onto the right side when you fold it down the center. Same thing with this triangle. Once you fold an isosceles triangle along the apex to the base with that perpendicular line, it will perfectly match. Left side will match onto the right side. Now, that perpendicular line will also refer to as a symmetric line. Now, why would that line be symmetric? It's because that line passed through the point where the left side of the left triangle is a mirror image of the right triangle. And that is what makes it symmetrical. So once you have left side mirrors the right side, the line that passed through that image where you fold the image through is called the mirror line, or it is also called a line of symmetry. All right? So that's something to bear in mind. And so for that reason, these two triangles are similar triangles, and so their base angles are equal. And that also will help you in terms of determining angles within the isosceles triangle. Because once you know one base angle, automatically you would be able to find the other base angle. And you know that the base angles occur with the unequal side. So if you know the unequal side of an isosceles triangle, and you know one base angle of that unequal side, then you will automatically know that the other base angle would be the same. And so you could use one base angle to calculate all the angles in an isosceles triangle. So for instance, let's say that you know that this base angle here is 30 degrees. How could we find, using this one base angle, how could we find the apex angle, students?
Sir, would you add the similar angle and then subtract from 180?
Correct. So if you add the two base angles, what would you get? All right. So we know in terms of all triangles, the sum of all the internal angles of triangles, when you add them together, you should get 180. So if we're thinking in terms of the isosceles apex angles plus the base angles, we know that the apex angle, which is A, apex angle A plus base angle B plus base angle C will add up to give you 180 degrees. So that is something that we know. All right. And we also know that base angle B must be equal to base angle C. So we know that. So if we know one of the base angle, we automatically know the other one. So we can say from given this base angle C, we can automatically write the apex angle plus 30, because B will now be automatically 30 degrees. Plus 30 degrees again, because C is the base angle given as 30. And we know that that would be equal to 180 degrees. All right. So we could now calculate the apex angle. We can add these two angles. So we know that the apex angle plus the sum of those two angles, which would be 60 degrees, is equal to 180 degrees. And so the apex angle then would be equal to 180 minus 60 degrees, 180 degrees minus 60 degrees. And that would give us how much? The apex angle would be equal to
120.
120. All right, now suppose we wanted to find the angle of the two right angle triangle formed from the isosceles at the apex. Suppose we wanted to find these two angles at the top here. How can we find theta? Theta would be equal to
the
what?
angles at the top
Yeah.
and bottom. So would
The
you divide that answer by 2?
The angles at the top. So theta, which is one of the angle at the top, you would have to divide the apex angle. You divide the apex angle by 2. And we know that that would be 120 degrees divided by 2. And that would give us 60 degrees. So each of the apex angle, each of the angle in the right angle triangle of the apex would be 60. So this angle on the left hand side at the top would be 60. This angle on the right hand side at the top will also be 60 degrees. Is that clear, guys?
Yes, sir.
All right. So these are some properties of isosceles triangle. So let us see, based on the ones that we have listed here, let us see what we know about these properties. So the first property is that the perpendicular line from the apex at A to the unequal side bisects the unequal side. Now, is it the first that you guys hear in the word bisect or bisects?
No, sir.
All right, so can you tell me exactly what bisect means?
So it's cut in half or make two parts.
All right, so when you bisect something, it cuts it into two equal parts.
Yes, sir.
All right. So we are saying that that perpendicular line bisects the unequal side, that it cuts the unequal side, which is the side that it is sitting on, into two equal parts. That's why we have BD is equal to DC. Where is it? X. All right, so here we have BD equal to CD. All right. Now the perpendicular line from the apex also bisects the apex angle. So the apex angle, which is A, it is cut into two angles by that vertical line or that perpendicular line, such that you will have one angle, the angle BAD, which would be the left side of the isosceles or the left right angle triangle at the top. So the angle would be BAD. Now, one of the things that I want to point out to you in terms of triangle notations, when you're labeling angles with the vertices, if you're using three letters like BAD, what you must always remember is that the angle is where the middle letter is. So the angle occurs where the middle letter is. So if we say angle BAD, that means the angle would be at A. And if we say angle CAD, it means that the angle still occurs at A. So that's one way when you're reading your angle. So if we are talking about the angle ABD, where would we find that angle? Not hearing you, Ms. Brown.
At B.
So yeah, so the angle would be at B. So that's the angle that this notation is referring to. So the angle at B here would be alpha. And based on our calculation, or based on the given angle at C, we know that it would also equal to the angle at C, which would be the angle C, or rather, let me correct that. So it would be the angle ACD. All right, so these would be the base angles. All right, is that clear, guys? All right, so the second property says that the perpendicular line from the apex also bisects the apex angle. And so that would give you angle BAD is the same as the angle CAD. Now, other properties. Now, the base angles, all right, other properties with that, the side AB, which would also equal to the side AC. Those sides are the equal sides of the isosceles triangle. So the two equal sides would be AB and AC. Now, the base angles, as I mentioned before, would be ABD and ACD. and those angles be equal. So these are the properties that you must bear in mind when you're working with an isosceles triangle. Any question about the isosceles triangle so far in terms of its properties? Everybody's have an understanding of what the properties are? Raise your hand if you do, please. Is there anything that you're not so clear on and you'd like me to clarify for you before we move on? All right, so I'll take it that everything I've said so far is clear to you and your understanding. All right, so I'm just going to clear what I have here on the screen. All right, so moving on now to how we can apply Pythagoras theorem to our isosceles triangle. Now here we have a question. Now, what I would like for you to do for me is to construct the isosceles triangle based on this question. And I will just allow you to just go straight ahead and try to solve the problem. So the problem here is that they want you to find the altitude of the triangle. That's part A of the question. And you have to calculate the area of the triangle. Now, what I want you to do, so let me allow you to do part A first, and then we'll go through part B together. So I want you to construct the isosceles triangle, apply what you know based on what the question gives you, and also apply what you know based on Pythagoras theorem and see if you could calculate the altitude. Everybody is okay with the word altitude, what it really means? Is everybody okay with the word altitude?
Sir, height.
Okay, so it is the height from the apex to the base. All right, so it's a vertical line from the apex to the base that they're asking you to measure. All right, so with that said, you may start the question. If the Zoom runs out, you know exactly what to do, guys, all right? So I'll just give you a couple minutes to do this question, probably about 5 minutes or so.